This exercise is to prove two given equations using trigonometric identities. For the first equation, we have some trigonometric functions of 2 theta and 4 theta on the left-hand side, and on the right there is only 2 theta. This implies that we need to reduce the angle of 4 theta to 2 theta. If we simply combine the two fractions into one, we will notice that in the numerator we have the product of sine 4 theta and cosine 2 theta minus the product of cosine 4 theta and sine 2 theta. We can actually treat 4 theta and 2 theta as two different entities. This enables the use of the following subtraction identity. So 4 theta is in the same position as x, and 2 theta is in the same position as y. We can therefore combine the numerator into sine of 4 theta minus 2 theta, which naturally becomes just sine 2 theta and can be eliminated with the sine 2 theta in the denominator. So we end up with 1 over cosine 2 theta, which is the same as secant 2 theta. This proves the first equation. Let's move on to equation number 2. The same angles of 4 theta and 2 theta appear on the left, but on the right it is just theta, so we probably have to do a bit more reduction. We should start with the bigger one, which is 4 theta. There is this double angle identity where sine of 2 times of an angle is equal to 2 times the sine and cosine of that angle. So if we treat 4 theta as 2 times 2 theta, we can write sine of 4 theta as 2 times sine of 2 theta times cosine of 2 theta in both the numerator and the denominator. Immediately we can see that 2 times sine of 2 theta is a common factor. So factoring it out in both the numerator and denominator, we can eliminate it entirely. Now we are just left with cosine of 2 theta in both places. We can apply another double angle identity where cosine of 2x is equal to either 2 times cosine square x minus 1 or 1 minus 2 times sine square x. The reason we want to use both of them is because on the right hand side we have cotangent square, which is the quotient of cosine square to sine square, so we need to work towards that form. And in the numerator we should replace cosine of 2 theta with 2 times cosine square theta minus 1. And in the denominator we replace it with 1 minus sine square theta. So this actually gets rid of all the 1's, and we're just left with cosine square over sine square with a minus sign. So therefore equation 2 is proved as well.